Okay, so further to discussion on matrix and matrix multiplication. So we'll proceed on desktop. This is Linux Mint. Okay, so we'll go slide by slide and we'll see what is the magic. So M for matrix and M for magic. Okay, so matrix and matrix multiplication. So a linear multiplication, cross multiplication, matrix multiplication, matrix notation, matrix multiplication. Okay, so what is linear multiplication? If x is input and it is attenuated by w and it becomes y, then y can be called w into x. This is linear multiplication. Okay, so no much intelligence is required. Okay, so x1 multiplied by w1, okay, and then x2 multiplied by w2 becomes y. Okay, so y, if I see y, there are two input signals. One input signal get attenuated, another input signal get attenuated, and both are added to become y. Okay, this is kind of cross multiplication. Okay, now there are two output, y1 and y2, and there are two input. Okay, so can we see both inputs are connected to both output and each has a different weight. So altogether, if we come to a calculation, then y1 equal to w11, w12, y2 equal to w21 and w22. So first one 2 belongs to kind of output and next one is input, and this is like this. Oh, okay. Now, so this is matrix multiplication. Whatever we saw, y1 equal to w1 x1 x2 and y2 equal to w21 w22, we can write like this: x1 into x1 x2, this is a matrix, multiplied by another matrix to result in output. Okay, we can specify like this also. This is matrix, this is attenuation, this is input to result in output. What will happen if this is matrix notation, okay, square bracket, means partial square bracket, and so if I multiply these two, then first row will multiply with first column and then first row will again multiply with first column to generate one row. Okay, here first row, okay, so here it will be x1 and x2 in transpose, but we represent like this, we can represent like this, so it should be kind of T transpose okay, so we call it T, or we can write like this: x1 and x2, this way. Okay, or we can write like this, the way we wrote, and we can just say kind of it is transpose. Okay, back to business. Okay, it can be written like this. So, means it is understandable what we want. Oh, can we now say there is input and there is a media? M is media, input is multiplied with media, into is mixed with the media to become output. Input mixed with multiplied with media to become output. Now rather than saying y1 equal to w11 x1 w12 x2 and y2 equal to w21 x1 w22 x2, we say x multiplied by media to result in y. So that is matrix kind of computation. Okay, so now we'll kind of proceed further. Now there are 4 inputs and 3 outputs. Now as per the calculation, this would result like this: 4 inputs, 3 output. Now 4 input multiplied by the media and generator. Now as per the discussion, can we see this? Okay, so the column and row there are 2 things. Column specifies input. Okay, I mean we are in other fashion the way I am describing. So okay, so here it will be other way, the way. Okay, so here the column is output and the row is input. Okay, or we can write like this: which is multiplied by x that is also possible, and which is multiplied by this, the way we described. For sake of clarity, I can just say this is transpose. Okay, now these guys would shift now. This will go here. It is little intricate work. This guy would shift here, this guy would shift here, and this guy would shift here. Okay, so like this. Now Mr. This would go there because it is like that. Now 2 1, 2 2 and 2 3. So 2 3 is here. It will go here. And 2 4. It will go here. Now 3 1, 3 2, 3 3 and 3 4. Okay, so we are done. So this is also possible. Okay, now in this case the columns are input and row are output which way we are multiplying. So when we see two things, two matrices, one matrix, another matrix. Okay, let's go by this fashion. If I see two matrices, one matrix or other matrix, one is input and one is the media. This is the media, this is the input, or in this format, this is the media and this is the input. Okay, in this format, the media columns are input and rows are output. So if their rows are output, there are 3 outputs and 4 inputs that we multiply to get the output. Okay, now what about, there are 2 set of inputs. One set of input and another set of input. So one of set of input will pass through the media to generate first set of output, and then next set of input would pass through the media to generate next set of output. Okay, so this can be described like this. There are 2 rows in the input. First set of input, second set of input, pass through same media and to generate the output. Same thing, one input pass through the media to generate the output. Second output generated by passing the second input through the media. All together we can say x multiplied into m equal to y. Okay, x can be multi-input, then y will be multi-output, but media would remain the same. Okay, now here the input passes through the attenuation to generate output. Again it passes through second attenuation to generate another set of output. We can say that x multiplied by m1, whatever result in, that is multiplied by 2m2. Okay, so these are kind of iterative. Okay, so as we say, if there are 2 matrices, one is input and one is media, combine becomes output. We cannot reverse it. This cannot become input and this cannot become media. Means input is completely separate than media. If I see that as per the multiplication we can reverse the order, but it's not possible. Media cannot become input and input cannot become media. Means physically they are different. Okay, so it won't multiply. This is first row will be multiplied with the first column, so it has to be 3. Okay, so it's not possible. Okay, so in lab session, first we see the matrix multiplication. So that anyway we'll see now. And in next lab, we will see OpenGL concepts. So that's what we are kind of bragging, OpenGL concepts. So that we'll see in the kind of the lab session. Now, there are many attenuation. One is translation attenuation. If there is a translation matrix, and if I pass a coordinate, then it passes through it and new coordinate is translated. If I pass a coordinate to rotation z media, it is rotated along z-axis. If I pass an input to a media, that is rotation along y-axis, it is rotated along y-axis. I mean I can combine all 3 media. So, okay, so x is translated, rotated, again rotated to generate y. This also we can see. So, now what we are kind of trying to say is x in OpenGL we reverse it. So, x is first, it is kind of translated, then multiplied by z, then multiplied by y. Or in other terminology, z is multiplied by y then t, it becomes an essence. Essence is a very big thing in mathematics. Essence. Okay. So if there is a vector, what is its essence along x-axis and y-axis? Okay. So if there are three matrices, how much essence it generates, so that if I multiply it with yx, then it will be y, means, okay, so if it is x is along x-axis, y-axis, z-axis, this is the net computation. This is the net vector. This vector will multiply with this vector to generate y. Okay, this as per the theory, we will really see something. So this is a submarine. And submarine, this is the initial position, and will pass through kind of many attenuations, many media, and finally it will kind of it will dance like this and it will become like this. Okay, so it will do many transformation to become like this. Okay, so we can start our fundamentals. Okay, I'll make sure that it won't be complex. It should be in a kind of boundary of matrix discussion only. Okay, so the concept here is that there should be a matrix. So now I have a program and I have, okay, a translation matrix minus 20. What is translation matrix? So that will print and see. Okay, we can kind of omit right now drawing anything, and we'll see what is the translation matrix. Okay, so this is translation matrix we are receiving. So we can say that this is the translation matrix, and what we have done, translation matrix of translating kind of along minus 20 z axis. So that is the translation. So we'll just save it. Okay, so I can say ABC, okay, translation towards z axis, and this is numpy array. Okay. Okay, so this is ABCTZ. Now, okay, so if it is not there, there is no translation, and I draw the shape what we are planning to, how it would look. Will it draw? Okay, so there is nothing. Okay, so probably little bit will try. So I'll say translate only something like 2. Because OpenGL has, oh, okay, so this is what it is drawing, means at this is near the origin, minus 2 only. Now what we are saying is, if it passes through translation matrix, what will happen to x? Okay, so now this is translation matrix of 20. So I will have a Python session. Now I can say like import math, import numpy as np. Okay, now A, B, C. So we'll copy paste this. This is the transformation matrix, in the sense this is the matrix. This is what it is. Now we will see what is the multiplication. So I'll say A, B, C, T, Z matrix multiplication of NP array, and then I have like this. Okay, this is the beginning position of our model. If we see, so our submarine is like this. So this is in what along y axis. So I have set y as 1, and this is fourth parameter as w. Okay, and d type equal to float equal to np float 32. Can we see something? Now our input is 0, 1, 0. This is input, and it is passing through a matrix. So that is translated matrix. So this is the matrix, translation matrix. And after translation, it became like 0, 1, minus 2. It shifted. Now y is 1, but z became minus 20. So it is translated. Okay, so now I can show the output. Okay, so it is translated 20. Now okay, now it is in z direction. We can show, there is no hesitation showing that. So we can show that it is really in that much in z direction. So I am rotating the complete axis. Okay, and I believe it cannot be shown so easily. I can try rotating along y axis. Okay, trust me that it went 20 kind of unit backside. That's why it is small. Otherwise, we saw that it was very big in size. So if I translate more, it will become smaller. That much translation it will do. So if I translate it to 40, it will become smaller. It became smaller. That distance it traveled along z-axis. Okay, now what about other like rotation along z-axis? I can rotate along z-axis. Okay, so we'll see what is z-axis matrix. This is time consuming, but it is worth it. Now I don't want any translation. I am going to rotate 10 degree along z-axis. What is the matrix, the media matrix that we are going to see? This is this much. Okay, if I rotate along z-axis, okay, so this would come like this. Now I'll copy paste to whatever file we are editing. So I would say this as abcz equal to np dot okay. Now So back to same story. Now I'll say this is A, B, C, Z. Okay. Now if I multiply A, B, C, Z with my input, okay, 0, 1, Y, only along Y direction it is there, what it would result in? Okay, it results output as everything is fine. Y has lowered down little bit and it shifted in minus X direction. Okay, so that we'll see. What we are saying now is, okay, so if now if this is the line, this is what we are doing, 0, 1, 0, okay, it would tilt little bit, and it would tilt, but height would go little bit low. In X direction, it would tilt like this. This is what it is. Height would lower little bit, and in minus X direction, it would tilt little bit. So probably I think GLU perspective. So that we have set 1 to 5t. So what we'll do is, we'll translate little bit so that it should be visible, and that much rotation we can do. So we'll translate something, we'll leave it 20 and we'll rotate like this, Z axis, and then we'll see if it is same. It is exactly same. See? It is exactly same. Means it passed through the media, it passed through the rotation media, rotation matrix, and it became like that. Okay. Now we can kind of rotate along y-axis. So this is y-axis, this is new y-axis. Y-axis shifted. So we can rotate little bit. So can we see what it is? So probably we can just save it. Okay, this is the output. Okay, so we'll rotate along y-axis, and then we'll see the output. Okay, so this is the matrix along the y-axis, but there is minus 20. So what we can do, anyways, so we'll see the kind of the computation, what we do. So if I do open a Python, put numpy as np and abcy equal to and now I'll do the input whatever we have done. Maybe I can type in. So we are doing like np dot abcy multiplied by np dot array, and array is 0, 1, 0, 1 dot 0. Okay, so there is no change, we can see. So only change in rotation, but in translation there is no change. And if we see these two, okay, so this has changed the way we stated here, but this has no change. But if we see clearly, this one is rotated. This is front, but this is little bit tilted. Okay, so now we are done. Now I'll save the okay, so I'll mask it and I'll generate again and we can save it. So we'll prove, so this is Y. So I can say ABCY equal to NP dot. Okay, now the idea is that if there are three kind of media, now we see kind of translation, we see rotation, each media how they kind of behave the input. If input is passing through all three, okay, what would be the media? Okay, so if that is the case, then I am going to enable all three and we'll see what is the media. Okay, this is the final media. So that also will copy. ABC equal to this is the final media. Now, as per our formula, the final media is nothing but this. Okay, or we can go one by one multiplying x and like this. But final matrix would be like this. So I can just copy paste this and we see if it really matches. So that is the kind of matrix multiplication we are talking about. So I'll say Python 3 import numpy as np. I'm going to paste it. Now okay, so I'll copy paste again. Import numpy as np. Now I have, this is the net. Now I have ABC, Y, Z like that. Okay, so as per the formula, this is we'll type in ABC TZ and then matrix multiplication ABC Z matrix multiplication ABCY. If both are same, they are exactly same. Okay, ABC, whatever we calculated, whatever OpenGL is calculating, whatever our formula is saying, both are exactly same. Okay, if they are exactly same, what will happen to Mr. Whatever we are kind of done, we have done. So I'll say now and then np dot array and 0 1 0 1.0 d type dot np equal to np float 32. Okay, so and in both cases it would be same. Whatever calculated from OpenGL, both would be same. ABC. Okay, so both are same. Now same thing what we are saying. Now in y little bit and x. So now same thing is coming, what we saw. Now we'll execute it and we'll see. Okay. Okay, so what we learned here is, so now I am going to show the real session. So I'll remove this rotation and I won't print it. So only kind of, so what we have achieved now. Okay, so now I am doing translation. So we are applying translation matrix, and when we are applying translation matrix, our input is changing. So actual input is like this big. Actual input is very big. First we translated it to -20 and it reached like this. Now I can translate with X matrix. I can translate with X matrix. This is little bit, it is rotating because of it is perspective projection. So it should be okay. And I can do up and down. Okay, I can kind of so we are rotating with matrix, that is rotation X, rotation Y, rotation Z, okay. So okay, so this is the submarine, what we have printed here. Okay, so it is little flat. Okay, so what we have done here, we have passed the input through many matrices and then we are seeing the output. So the beginning is, so the beginning is like this. It started with this and now it passed the various matrices and its resultant is like this. Okay, we can do whatever we want. So kind of if I like it is kind of moving. So it is passing through various matrices and then input is, it is passing through various matrices and input is becoming output, and then we see the transformation of this to this.